Welcome to the deep dive. Imagine a library containing uh, literally every piece of human knowledge. Now imagine you only need like a pancake recipe.
Right, so if you turn on all the lights in the astrophysics wing, you're just wasting massive amounts of energy.
Exactly. And today's deep dive is all about how an 81-page guide on Alibaba's Qwen Max 3.8 shows they actually solved this AI energy crisis.
Yeah, and how it's basically going to completely change your day-to-day workflow.
Okay, let's unpack this because the scale here is just staggering. We are looking at a 2.4 trillion parameter AI.
Which is huge. I mean, almost unimaginably big.
Right. But using that library analogy, Qwen Max uses a mixture of experts architecture. So out of those 2.4 trillion parameters, only 95 billion are actually active at any given time.
And that selective activation is honestly the only reason a model this massive doesn't just collapse under its own computing weight.
It routes your prompt, right?
Exactly. The system categorizes your prompt and routes it only to the specific neural networks, the experts that are trained to handle it. So you get the intelligence of a massive model for the energy price of a much smaller one.
But, well, turning on the right lights in the library is only helpful if you actually have the desk space to open all the books at once.
Which brings us to the context window. We're looking at a 1 million token memory here.
A million tokens, that's what, thousands of pages?
Yeah, easily. In the past, dealing with massive data meant building these really complex vector search pipelines. You'd basically chop a huge document into tiny paragraphs and just hope the AI grabbed the right piece.
Which was always kind of hit or miss.
Very hit or miss. Now you just dump multi-hundred-page documents or entire code bases right onto that massive reading desk. It natively ingests the whole thing simultaneously.
Okay, I'm stuck on the reliability of that, though. Like, if I have a million tokens open on a desk, I am definitely going to forget a crucial detail from page 42.
Oh, for sure, a human would.
Right, so how does this system actually manage retrieval accuracy across such a sprawling context without losing the plot?
Well, what's fascinating here is how the long context mechanics preserve really high-fidelity recall without just skimming. The architecture actually forces the AI to map relationships across the entire dataset.
So it's not just holding it, it's connecting it all.
Exactly. For highly domain-specific tasks, like parsing dense regulatory contracts for legal synthesis or mapping out graduate-level STEM proofs, it holds all those critical variables in place without dropping the thread at all.
Wow. But having all those books open and remembering them is kind of useless if the AI can't logically process the information, which gets us to how this thing actually thinks.
Right, and it operates on dual reasoning modes, so developers can toggle between like a fast intuitive mode for standard tasks and an explicit thinking mode for deep logics.
And in that deep mode, it uses chain of thought tracing, right?
Yeah, it explicitly breaks down complex logic step by step. That allows a developer to actually trace and debug its math.
Here's where it gets really interesting. They apply this deep thinking to long horizon agent workflows. The AI uses React Loop's reasoning and acting to actively pilot web browsers and APIs over multi-step sequences.
Yeah, it plans, executes, and then course corrects on its own.
But honestly, if I have an AI running an automated browser, thinking step by step through a million tokens of data, the server costs would literally bankrupt a normal startup in a week.
You would think so, yeah.
So there has to be an economic workaround for this to be sustainable.
There is. If we connect this to enterprise FinOps, the solution is something called prefix caching.
Prefix caching, wait, how does that work?
Because reading a million tokens requires massive computing power, prefix caching essentially saves the AI's memory state after that first read.
Oh, so it doesn't start from scratch every time.
Exactly. When the agent acts and loops back for the next step, it just references its saved memory. That slashes compute input costs by up to 80%. It fundamentally changes the ROI of autonomous execution.
That's wild. So the compute is cheap and the AI is smart. That means we really have to look at the real-world friction of deploying this.
And the immediate vulnerability there is enterprise security. I mean, a 1 million token context window is a massive surface area to defend.
Because you're pulling in entire code repositories or hundreds of web pages autonomously.
Right, which opens the door to data poisoning. Malicious instructions can be secretly hidden inside those large files to hijack the AI's behavior.
Yeah.
Organizations have to build entirely new defense layers before unleashing this.
Especially as we move toward fully integrated omnimodal systems.
Exactly, where it's processing text, vision, and audio all at once.
So what does this all mean? The guide points to a future of persistent autonomous agent swarms. We are moving past AI that just answers our questions toward AI that operates continuously, managing long-horizon tasks 24/7.
Which raises a really important question. As these swarms become cheap and highly capable, will you become a manager of digital experts rather than a doer of the tasks yourself?
Think about that. When you no longer have to wander the aisles of that mega library, and instead just manage a swarm of assistants turning on the lights exactly where you need them, what will you choose to build? Something to ponder.